Okay, we are going to figure out if log of quotient is equal quotient of logs. So let's check logarithm of a over b, whether or not equal to log a over log b. So let's do some simplification. Let's see. Based on property log a, log a over b equal log a minus log b, right? And that is equal log a over log b. Since common denominator is log b, so I'm going to multiply and divide the other part, the left side, by log b. And drop denominator, obviously. So as a result, we are getting log a log b is minus logarithm square b. Pay attention, not logarithm b squared, but logarithm square b, two different things. And that is equal log a. Okay, so I'm moving log a to the left side and log square b to the right side, and I'm getting log a log b minus log a, and that is equal log square b. Taking out log a is a common factor, and I get log b minus 1. And log square b, based on property, is equal twice log b. Real quick, log a by base p is equal p times log a. Okay, so from here, what does that mean? Here we have multiplication product, here we have product. That's mean we have to this equal sign to be valid. So either we have log a equal to and log b equal log b minus 1, which is nonsense. Log b can never be equal log b minus 1. Or if we take vice versa, if we take vice versa, let's say log 1 minus b log b minus 1, let's say equal to, then my log a has to be equal log b, which means that lose the meaning in the original question, because if I'm dividing by itself, and then condition, there is going to be also a requirement that log b minus 1 equal to, so it doesn't work practically. Okay, which means it cannot be valid. Now let's confirm with practicing a couple of problems. Let's say I am taking, for example, which one? Okay, let's take logarithm 625 over 125 by base b, by base 5. It's going to be equal logarithm 625 by base 5 minus logarithm 125 by base 5. You can take any logarithm, any base. I just took the ones that easy to work with, so that there is the whole number result. Okay, so this is equal 5 to power 4 is equal 625, and minus 5 to power 3 equal 125. So result is equal 1. Now let's take logarithm 625 by base 5 divided by logarithm 125 divided by base 5. Since we already know 625 by base 5 is 4 and divided by 3, so which means it's not equal to each other, right? So we get 625 over 125 by base 5 is not equal log 625 by base 5 over log 125 by base 5. Another example, let's say log 81 over 9 by base 3. Okay, this is equal log 81 by base 3 minus log 9 by base 3. This is equal 4 minus 2 equal 2. Okay, now let's do the other way. Log 81 by base 3 divided by log 9 by base 3 is equal 4 divided by 2. Now this is just a coincidence. This is just a coincidence. It doesn't mean it's because it just happened that 4 minus 2 is 2 and 4 divided by 2 is 2. That's all. Let me take another one. Let's say log by base 2, 256 over 8. That is going to be equal. Log of 256 is 8. Log 8 by base 2 is 3. We are getting 5. Now if we do the other way, 256, log 256 by base 2 divided by log 120, log 8, I'm sorry, by base 2, it's going to be equal 8 over 3. Okay? And another interesting case also I would like to look at. Let's take log 10 over 1 by base 10. This is going to be equal log 10 by base 10 minus log 1 by base 10. And this is going to be equal 1 minus 0, right? Equal 1. If we take log 10 by base 10 divided by log 1 by base 10, we are getting 1 over 0, which is infinity in calculus. Okay? So this formula is not valid. Okay? Moving to next question I would like to cover. So, if log a plus b is equal log a plus log b, well, based on property it's not equal, but if it is equal, let's say just some coincidence, just like we had here, coincidence with 4 and 2, remember? This and this, just same coincidence can be here. If it is, this equation is equal, but let me repeat myself, based on property is not equal, usually. So then we need to find a, then find a through b. Okay? Here is our question. Okay, so let's do it. Logarithm a plus b is equal, based on property of logarithm, it's going to be logarithm a b. Yes? So what do we know? If logarithm with the same base on both sides of equation is equal, is the same, then we can say that a plus b is equal ab. Let me write down this rule. if logarithm a by base b, let's say, equal logarithm c by base b, not base b, b is the same, right? 10 and 10. Then, hence, a is equal c. Let me move this way and move this one. This symbol means hence. Okay, then a is equal b. The same way we are writing down a plus b is equal ab. So from here, a plus b, if we divide both sides by a plus ab, divide by ab, we are getting a plus b over ab is equal 1, right? So let's separate our fraction, make it denominators, put it as a separate denominator. This is equal a over ab plus b over ab equal 1. And here we have, this is gone with this is gone with this. And we get 1 over b plus 1 over a is equal 1. So from here, 1 over a is equal 1 minus 1 over b. Okay, 1 over a, I am bringing to common denominator b, which is going to be equal b minus 1. And from here, if 1 over a is equal b minus 1 over b, then a, since this is our, let's say, 1 over b is same thing as a to negative 1, right? So if I flip it, right? 1 over a, if I flip a over 1, it's going to be equal b over b minus 1. And here we have the result. We express a through b. A is equal b over b minus 1. All right. And moving to the third one. Third question I'm going to solve. It is, I would say, for math lovers who loves math. So whoever is going to be interested in seeing solution, you have to take your patience because it's going to be a little bit longer solution, but it's going to be very interesting. Okay, so we are going to use tricks in there. All right, here is the question. If a plus b plus c is equal 1, a squared plus b squared plus c squared equal 2, and a cubed plus b cubed plus c cubed is equal 3, then how much is a to negative 1 plus b to negative 1 and plus c to negative 1? Question mark. Okay. So, let's start solving. A squared, a plus b, actually, a plus b plus c. I'm taking squared and doing minus a squared plus b squared plus c squared. Okay, let me show you why I'm starting from this way and what for. So, yeah, I should have shown you from the beginning. Okay, it's still not late. Let me show you. So, we know that a to negative 1 plus b to negative 1 plus c to negative 1 is equal 1 over a plus 1 over b plus 1 over c, right? if I bring to common denominator, which is going to be ABC, so meaning here we multiply by BC, multiply by BC. Here we multiply by AC, multiply by AC. Here we multiply BA, multiply by AB. So it doesn't matter BA or AB, right? And we are getting from here ABC, common denominator, right? And that will be in numerator BC plus AC plus AB. So the whole task is boiling down to find how much is ABC and the sum of polynomial BC plus AC plus AB. Okay? All right, now let's go back and solve it. So, a plus b plus c squared, I am doing minus a squared plus b squared plus c squared. So, where a plus b plus c is equal 1, right? So 1 squared. And minus a squared plus b squared plus c squared is equal 2. So that is equal -1. Okay, now let's open a squared, a plus b plus c squared. That is equal a squared plus b squared plus c squared. It's formula a squared, a plus b plus c squared. Just like a plus b squared. So that's equal a squared plus b squared plus c squared, and then plus 2ab. So all versions of 2ab plus bc plus ac. All versions. So this is formula for a plus b plus c squared. Okay, let me write down here. A plus b plus, we learned for 2 terms, right? Perfect square. For 3 terms, it is equal, move here. So that is equal a squared plus b squared plus c squared minus twice ab plus bc plus ac. Okay? So, we have here 2ab plus bc plus ac. We opened it. And I am doing minus. Opening second parenthesis, minus a squared minus b squared minus c squared, where all of them are canceling each other. And the result is going to be twice AB plus BC plus AC, right? And that is still going to be equal -1 from here, right? Because it's the same thing. Is equal -1. Okay, now if I divide by both sides, 2AB, let me rewrite it clean. Twice AB plus BC plus AC is equal 1, -1, I guess. Yeah, if we divide by AB plus BC plus AC, and no, I'm sorry. What am I doing? I won't divide by 2. I need AB plus BC. I need this piece to find out. So I need to divide by 2. Sorry. Dividing by 2 here. Divide by 2 here. And we are getting from here AB plus BC plus AC is equal -1/2. Okay. So this is our first part. See, here we have BC plus AC plus AB is negative 1/2. Much more interesting, it's going to be, and complicated, it's going to be find the product ABC. So let's go for it. The journey is starting here. All right. So, since we have, it's given, let me change the color here. I'll start using green one. Since we know that A plus B plus C is given equal 1, right? Hence, I can put down that A plus B plus C cubed is equal 1 cubed, which is same 1. Okay, now this I'm A plus B plus C cubed, I'm breaking down into A plus B plus C squared multiplied by A plus B plus C, and that is still equal 1. Now I'm opening A plus B plus C. A plus B plus C, we got it from here. See? A plus B plus C squared. I'm going to write down. And it's going to be A squared plus B squared plus C squared plus twice AB plus BC plus AC, right? Take all this in square brackets and times A plus B, okay, plus C. Let me change the color so you will know what it belongs to. Okay, and it's equal 1. Next step, I'm getting rid of parentheses in the square bracket, and that is going to be A squared plus B squared plus C squared plus 2AB plus 2BC plus 2AC. So let me move this a little bit on the side. And this A plus B plus C, I'll put in front because it's easier multiply the parentheses with less term, right? A plus B plus C, like that. Okay? So now I'm going to multiply these two parentheses. Okay, wish me good luck not to slip and make some silly mistakes, because math and silly mistakes go hand by hand, as you know. And I'm not telling you any news. Okay, so how I'm going to multiply? I will change, so I'm taking, let me see, I'm going to do this way. B, so it would be clear for you. This is gonna be green, and green, and this one I'm going to keep it this color. So based on colors you will know what I multiply by what. So I'm going to go the following way. First A multiply by every single one, okay, and then move B multiply by every single one, and then C. Okay, that's how it's gonna go. You can follow me. So I'm starting with black color because I'm multiplying A by entire second parenthesis. So it is going to be A cubed plus A B squared plus A C squared plus 2 A squared B plus 2 ABC plus 2 A squared C. Okay, moving to green color, now I'm multiplying B. So it's equal, plus B A squared plus B cubed plus B C squared plus 2ab squared plus 2b squared c plus 2acb. Done. Moving to multiplication of c by entire parentheses. It's going to be plus a squared c plus b squared c plus c cubed plus 2abc plus 2bc squared plus 2ac squared. Okay, this is what we are going to get. First of all, cubes, the term to power 3 cubed, they don't have any like terms, so I'm separating right away. Let me this write down equal 1, because it is equal 1, right? So I'm getting a cubed plus b cubed and plus c cubed. We have there. It's right here. A cubed. Here is c cubed. And somewhere has to be b cubed. Here it is, b cubed. Okay? Next. Plus. I'm going to combine like terms, which is going to be, where is it? AB squared, let's see. It's going to be AB squared, and where is else? I have 2AB squared right here. So it's going to be 3. It's becoming 3 already. 3ab squared. Next, we are going to have ac squared plus 2ac squared. It's going to be plus 3ac squared. And then it's going to be 2a squared b. Where do we have a squared b? It's right here. It's going to be plus 3a squared b. And we are going to have ABC, several of them. Let's see, here is 1. Here is 2. And here is 3. So we are getting plus 6 ABC. Okay, let's see what we have left. We have left 2a squared c. 2 wavy underlines. 2a squared c. Where is it? Here it is, a squared c. So it's going to be plus 3a squared c. And then we have bc squared. I'll put line and wavy line. bc squared. Here it is. It's going to be plus 3bc squared. And we have left b squared c. So I'll make it 3 underlines. 1, 2, 3 plus 3b squared c. And this is still equal 1. So this long expression. Okay, so let's see what is interesting. We need to find our ABC subject. All this long multiplication we are doing to figure out ABC. All right, so what do we get here? A cubed plus b cubed plus c cubed is equal 3, right? It's given from the very beginning. Let's go back and check. Here it is, right? Okay, coming back. So what else we are going to get? So we'll figure it out as we solved. I will put first one here, because we are going to operate. I need it so it will be in your vision. We are going to get 3 plus, I put 6abc, that's subject of my interest, and then plus the rest. What am I going to do? Taking 3 out, because every single one of them has 3, right? 3 ab squared plus ac squared plus a squared b plus a squared c plus bc squared plus b squared c. Okay, in all these 3 terms, we can take 3 out, right? We can divide by 3, and we are going to get 1 over 3 is equal 1 plus 2, because I divided by 3, right? And plus the whole the whole long parenthesis. And this is what I'm going to do. Look here, this is very interesting. I know that it is given to us that a plus b plus c is equal 1. Remember? Okay, so I'm going to combine these 2 parentheses, this, where else is b squared? Here, b squared. I'm going to combine and take b squared out. I will get a plus c. Next, ac squared, where else c squared? Here, plus c squared, taking out a plus b. Where else is a squared? Okay, and this one I'm getting a squared b plus c. Yes? So from here, what is going to happen? First of all, this one I'm moving on the other side, right? And I'm getting negative 2/3 equal. So it's gonna be 2ab, wait a minute, sorry, 6abc, it's gonna be 2abc. Shame on me, important term, all this mess because of that abc, and I forgot to put 2abc. I'm wondering, you are impatiently waiting to see when I will discover it. Okay, negative 2 over 3 is equal to ABC plus. So look here, we have a plus b plus c equal 1, right? So from here, I'm going to express through that equation, through that equation, b squared, a plus c, now let's say this one, a plus c, it's going to be equal, a plus c is equal 1 minus b, right? So I'm going to write down 1 minus b. Next, plus c squared, I'm going to write down 1 minus c, because a plus b from here is going to be, from this equation, it's going to be 1 minus c. And the third one, plus a squared times 1 minus a. Why am I doing this? You will see in a minute. So negative 2/3 is equal to ABC plus, I am distributing now this parenthesis, okay? B squared minus b cubed plus c squared minus c cubed plus a squared minus a cubed. Okay, negative 2 over 3 is equal 2abc 2abc plus, I'm combining together all this b squared, c squared, a squared, because it is given to be equal to, right? So I'm writing down b squared plus c squared plus a squared, right? And minus, so what I have left, negative b cubed, negative c cubed, negative a cubed. So I put minus in front of parentheses, and inside I get all positive, b cubed plus c cubed plus a cubed. And what do we have? My, this is 2, this is 3. See, I can now easily find 2abc. We have, excuse me, negative 2 over 3 is equal 2abc plus 2 minus 3. Since it's going to be equal negative 1, so once I move over, it's going to be 1 minus 2/3 equal 2abc, right? And this is equal 1 minus 2/3, it's going to be equal 1/3 is equal to abc, okay? And abc from here is equal 1/3 divided by 2. So 1/3 divided by 2 is going to be equal 1/6. All right, so we got ABC is equal 6. Now let's put the pieces together. A to power negative 1 plus b to power negative 1 plus c to power negative 1. After simplification we did, it was equal bc plus ab plus ac over abc, and we had, so first piece, it was at bc plus ab plus ac, it was equal negative 1/2. Let me go back. There we go, negative 1/2. Okay, negative 1/2, and we divide by 1/6, right? Divide by 1/6, and we are getting negative 1 times 6, and underneath is 2, which we get negative 3. So this is our answer. A to negative 1 plus b to negative 1 plus c to negative 1 is equal, let me make it really negative 1, it looks like some element, negative 1, negative 1, negative 1, and that is equal negative 3. And this is in case only and only if we have a plus b, if a plus b plus c equal 1, a squared plus b squared plus c squared equal 2, and a cubed plus b cubed plus c cubed equal 3. And we are done. Okie dokie. If you like it, such type of problems, put either like or in the comments, so I'll pick up more problems like that. It's fun. Okay, see you again.